This is where distributed transactions comes into play. A distributed transaction spans multiple systems and databases and ensures that they all come into the same conclusion. Either the reservation is confirmed. So if the hotel isn't booked, no one buys their flight. This prevents anyone from being stuck with a flight but no place to stay. Alright, and so what exactly is a distributed transaction? At its core, a distributed transaction is an operation that spans multiple systems or databases. It's different from a regular transaction which usually operates within a single system. Let's talk about the two-phase commit protocol. This is one of the most common ways to manage distributed transaction. Think of it like a project manager overseeing a group task, making sure that everybody is ready before moving forward. Hey everyone, welcome back to Prep Train. I am Sahib Kumar, and if you are new here, I'm so glad that you have joined us today. Our objective here at Prep Train is all about helping you level your skills and knowledge in backend engineering skills with practical tips, hands-on demos, and industry insights. If you are passionate about learning how backend systems work, whether it's about your favorite app handling million transactions or how data stays consistent across the globe, this is the place for you. We break down complex concepts into easy to understand lessons so that you can get hands-on experience and grow your expertise. Today's topic is something that plays a huge role in keeping the digital world running smoothly. Distributed transactions. Have you ever wondered how your payment goes through when you are shopping online, or how your data stays in sync across multiple systems? Well, distributed transactions are what make this possible. They are the backbone of keeping everything in sync, ensuring that no matter how complex the system is, it is either succeeds together or they fail together. If you are curious as I am about how all this works behind the scene, make sure you hit the subscribe button and turn notifications so that you don't miss any of our upcoming videos. Also, do join Prep10 Telegram community because we keep sharing latest internships and job opportunities over there as well. Okay, today's video is basically packed with valuable info. We will be covering the two-phase commit protocol, which is a key method used to manage distributed transaction. I will also share some real-world example that will make this concept crystal clear. So let me just bring my deck, and then we will continue diving deeper into distributed transaction and how they keep our data consistent across systems. Alright, let's start with the basics. What exactly are distributed transactions? To make it relatable, imagine you are going shopping online. You add a few items to your cart, hit to checkout, enter your payment details. But what happens behind the scenes? You are actually interacting with multiple systems, one for payment processing, one for inventory management, and maybe even another for shipping. So all of these systems needs to work together seamlessly to make sure that a transaction is completed correctly. This is where distributed transactions comes into play. A distributed transaction spans multiple systems and databases and ensures that they all come into the same conclusion. Either they all succeed or they all fail together. This is known as atomicity, one of the key principles in backend engineering. The main point to understand here is that distributed transactions are critical for maintaining consistency across systems. Without them, you will run into all kind of issues like your payment going through, but you are not actually reserving the items in your cart. Distributed transactions prevent this by making sure that all systems either complete their part or roll back their changes if something goes wrong. Now that we have got a basic understanding of what distributed transactions are, let's move on to a real world analogy to help you visualize basically that how this actually works. So let's break this down into a simple example. Let's think that you and your friends are planning a group vacation. Everyone is responsible for booking their own flight, but you all agree that you will only book if hotel reservation is confirmed. So if the hotel isn't booked, no one buys their flight. This prevents anyone from being stuck with a flight but no place to stay. And this is the perfect analogy for distributed transaction. Just like your group of friends, every system is involved in a distributed transaction and needs to be on the same page. If one system can't commit to the transaction, let's say the payment system fails, then none of the other systems should move forward with their part of the transaction. This way you can avoid inconsistencies like payment being processed but inventory not being updated or orders not being saved. In distributed transaction, this all or nothing approach is essential to make sure that all the system involved either commit to transaction together or they all roll back to the changes, leaving no loose ends. Now that we have looked at a real world example, let's dive into the core concept of distributed transaction and how they manage to keep everything in sync. Alright, so what exactly is a distributed transaction? At its core, a distributed transaction is an operation that spans multiple systems or databases. It's different from a regular transaction which usually operates within a single system. In distributed system, we are often dealing with multiple services or even databases that are located across different servers. The key principle here is atomicity, which ensures that all part of the transaction either succeed together or fail together. This is part of acid properties of transaction which are critical for maintaining data integrity. Let's break this down quickly. So atomicity is basically all or nothing. So either the transaction succeeds or none of it does. Consistency again means basically the system remains in a valid state before and after the transaction. Isolation is transactions don't interfere with each other, and durability is like once a transaction is complete, it's permanent even in case of system failure. So in distributed system, transaction needs to be handled carefully to ensure that all the systems involved are in sync. If one part fails, the entire transaction needs to roll back, so all systems return to their original state. This prevents partial updates which can cause major issues like charging a customer but not delivering the product. So now that we have understand what distributed transactions are and why are they important, let's dive into a specific technique used to manage them, the two-phase commit protocol. Alright, let's talk about the two-phase commit protocol. This is one of the most common ways to manage distributed transaction. Think of it like a project manager overseeing a group task, making sure that everybody is ready before moving forward. So how does it work? So two-phase protocol is broken down into two phases. So phase one consists of the coordinator. Think of it as the product manager, which asks all the participants that, hey, let's say all the systems or the databases that, hey, if they are ready to commit. So every participant checks whether they can successfully complete their part of transaction, and then they respond with a yes or no. If everyone say yes, we move to the next phase. If anyone says no, the transaction is aborted and no changes are made. So let's say if everyone says yes, then we go to phase 2, which is commit. So if all participants agreed in phase 1, the coordinator then sends a message telling everyone to commit. This finalizes the transaction and it makes all the changes permanent. So if something goes wrong even at this stage, the coordinator can still tell everyone to roll back, ensuring that there is no partial changes which remain in the system. So this protocol is critical for maintaining consistency across distributed system and preventing issues like partial payments or incomplete orders. It ensures that every part of the transaction is completed successfully or everything is undone, leaving the system in its original state. Now that we have covered how the two-phase commit protocol works, let's break down some key terms that you will encounter when discussing distributed transactions. Alright, so the term that I will be discussing right now, understanding these terms will help you better grasp how all components work together. So we have here components in coordinator, rollback, commit, and participants. Coordinator is basically the manager of the transaction. Its job is to oversee the entire process and communicate with all the participants involved. Think of it like a project manager who ensures that everyone is on the same page. So the coordinator is responsible for initiating the transaction, checking if all the participants are ready to commit, and finalizing the process by either confirming the commit or initiating a rollback if something goes wrong. Participant is basically an individual system or databases that involved in the transaction. They each play a specific role in ensuring that their part of operation is completed. For example, in an e-commerce transaction, let's say one participant might be payment system, another might handle inventory, and another manages shipping. So each participant must confirm whether they can commit to the transaction during the prepare phase, and if they can't, the transaction is aborted. Third thing is commit. So a commit basically means that the participant has successfully completed its part of transaction and it is ready to make the changes permanent. Once a participant commits, it confirms that everything is good on its end, and if the coordinator receives a commit signal from all the participants, it finalizes the transaction, making sure that all changes are made permanent across all the system. Last, we have here rollback. So basically, rollback is essentially an undo operation. If any participant encounters an issue during the transaction process, the rollback undoes any changes made so far. This ensures that no partial updates are left hanging. For instance, if the payment system fails, the inventory and shipping system will also roll back their changes, ensuring that transaction does not go through an incomplete state. Understanding these key terms is crucial because they form the foundation of how distributed transaction work. The coordinator manages the entire process, and the participant must either commit or roll back depending on the success of the transaction. So now that we have covered the key terms, it's time to see how distributed transactions are applied in real world use cases across various industries. So distributed transactions are not just theoretical, but they are used in many critical real world applications. Let's explore a few examples of how they are applied in different industries. Let's say a banking system. So when you transfer money between two banks account, especially between different banks, distributed transactions are applied. So let's say you are transferring money from account in bank A to a friend account in bank B. Here, both account or basically both bank needs to be in sync. Distributed transaction ensure that both banks either process the transfer successfully or roll back their changes if something goes wrong. This prevents situation where your account is debited but the other account does not receive the funds. The transaction must be atomic, meaning both banks must commit to it or neither proceed. So in case of e-commerce platform, distributed transaction are also essential for think about like when you make a purchase online. So multiple systems are involved in this process. Let's say there is a system for processing your payment, another for checking inventory, and probably one for shipping. So if any of this system fail, the entire transaction needs to be rolled back to avoid situation where you are charged for an item that's out of stock or not shipped. Distributed transaction ensure that all of the system either commit to the transaction or they cancel it entirely, keeping everything in sync. When we talk about microservices architecture, so basically in modern backend systems, microservices often handle different part of transaction. One service might be responsible for processing payment, another for managing inventory, and yet another for handling user notification. Distributed transaction ensure that all these microservices work together, ensuring that the data remains consistent across the board. So if one microservice fails to complete the task, the entire transaction is rolled back to maintain consistency. These use cases show that just how important distributed transactions are, and especially in large scale system where multiple components need to work. So whether it's ensuring that a bank transfer completes correctly or making sure that your online shopping experience is smooth, distributed transaction plays a critical role. Now that we have seen how distributed transactions are used in real world, let's summarize everything that we have learned up so far and let's just wrap it up. So let's quickly recap everything that we have covered about distributed transaction in this video. So at their core, distributed transactions are essential for managing complex operations that span multiple systems or databases. They ensure data consistency by making sure that all parts of a transaction either succeed together or fail together, preventing potential issues like partial update or incomplete processes. We also explored the two-phase commit protocol or 2PC protocol, which is a widely used method to manage distributed transactions. It works in two phases. First of all, prepare, where all system checks if they are ready to commit, and second phase is commit, where the transaction is finalized if everyone is ready, or rolled back if something goes wrong. This ensures that all systems are in sync before making changes permanent. Finally, we discussed some real world example in banking system. Distributed transaction ensures that money transfer between different banks are consistent and reliable. In e-commerce, they guarantee that payments, inventory, updates, and shipping, all tasks either succeed or fail together, avoiding issues like, double charges or missing items. And in microservices architecture, distributed transaction helps keep multiple services in sync, ensuring that the data remains accurate across all the board. The key takeaway is that distributed transactions play a critical role in maintaining the integrity and reliability of large scale applications. Without them, we will be risking data inconsistency, failed operations, and a poor user experience in many of the systems that we rely on every day. Thank you so much for sticking around until the end of today's video. We have covered the basic of distributed transaction, explored how the two-phase commit protocol works, and looked at some real-world examples of how distributed system stays in sync. If you found out this video helpful, please give it a like. It really helps the channel grow, and don't forget to subscribe and turn on notifications so that you can stay updated with all of our future videos. Your support is what keeps PrepTrain growing and allow us to bring more valuable content. Also, if you are looking for latest job and internship updates, or you want to connect with other in the field, join our PrepTrain Telegram community. Is the perfect place to stay informed and network with like-minded learners and professionals. Thanks again for watching, and stay tuned because we have got more videos on backend engineering coming soon. I am Sahib Kumar, and I will see you in next video.